Good morning, student. Today we'll discuss from properties of base or alkalis. Okay, we have already discussed up to ammonium hydroxide preparation method of bases. Now from here, first point is the bases have a sharp and bitter taste. Okay, base have a sharp and bitter taste. Okay, they change the color of indicators. Okay, like as acid. See, indicators, there are three common indicators we know that means first of all litmus, methyl orange and phenolphthalein. Okay, litmus, in case of litmus, color change from red litmus to blue litmus. Okay, red litmus to blue litmus. Now in case of methyl orange indicator, the color change will be from orange to yellow, and in case of phenolphthalein indicator, the color change will be colorless to pink. Okay, insoluble bases do not affect indicators, only soluble bases affected with indicators. Okay, but insoluble bases do not affect it with these indicators. Okay, now third point is they are soapy substances, they are slippery to touch. There are some bases, they are, the nature of the all bases are like soapy, that means slippery. Okay, they are soapy substances and they are slippery to touch. Now fourth point is they are strong electrolytes. Okay, why? Because base means what? Base means what? We can produce here ion. Okay, that means OH minus ion. That's why they are perform as a strong electrolytes. Now fifth point is they show a mild corrosive action, slight burn type on the skin. Okay, now the next property is chemical properties. Chemical properties. So first property is strong alkalis absorb carbon dioxide from the air to form carbonates. Okay, now see, when strong alkali react with carbon dioxide gas, they produce carbonates ion. Okay, or metal carbonates and also water. See, this is the reaction when sodium hydroxide, this is a one type of metal. Okay, you can see this is a strong alkali. Sodium hydroxide when react with carbon dioxide gas, it produces sodium carbonate and water. Same as potassium hydroxide react with carbon dioxide gas, it produces potassium carbonate and water. Okay, now second reaction is they neutralize acids to form salt and water. Okay, see, first of all, this is the calcium hydroxide and this one is the ferrous hydroxide. Calcium hydroxide and ferrous hydroxide, or you can say iron hydroxide. Okay, when calcium hydroxide react with hydrochloric acid, it produces calcium chloride and water. And same, when iron hydroxide react with hydrochloric acid, it produces salt and water. Salt of iron, that means ferrous chloride and water. Okay, now see the third reaction. The third reaction will be when metallic salt react with base, okay, or alkali, they will produce salt and insoluble hydroxide. This is very important. Insoluble hydroxide means we can see this hydroxide as a precipitated form. Is this clear? And also colored precipitated form. See, they precipitate as insoluble metallic hydroxides when added to the solutions of the salts of the heavy metals such as copper, iron, zinc, etc. See, metallic salt copper sulfate when react with ammonium hydroxide, this is weak base na? Okay, it will produce ammonium sulfate, NH4 ammonium sulfate and copper hydroxide. The color of the copper hydroxide is pale blue. Okay, when zinc sulfate react with sodium hydroxide, it produces sodium sulfate and zinc hydroxide. Okay, zinc hydroxide gelatinous white color will be gelatinous and color will be white, and the form of precipitate, the form is the gelatinous. Okay, state, that means physical state will be gelatinous. Now when ferrous sulfate react with sodium hydroxide, it will produce sodium sulfate and the precipitate of iron hydroxide. The color of the precipitate is dirty green. Now see, note, the hydroxide of zinc, aluminum and lead being amphoteric by nature, dissolve in excess of NaOH or KOH, but the other hydroxide don't. See, when zinc hydroxide is treated with sodium hydroxide, it will dissolve there. Okay, zinc hydroxide is dissolved in sodium hydroxide, that means it produces sodium zincate and water. Okay, now fourth point is when alkali reacts with ammonium salt, okay, that means when alkalis are warmed with an ammonium salt, ammonia gas is given out. Okay, ammonia gas is given out. The smell of ammonia gas is very pungent. See, these are the reaction. When ammonium chloride is treated with sodium hydroxide, it will produce sodium chloride, water as well as ammonia gas. Okay, see, ammonium chloride when treated with a base or alkali, you can say this produce calcium chloride, salt, water and also ammonia gas. When ammonium sulfate react with potassium hydroxide, okay, after giving some heat, then it produce potassium sulfate as a salt, water and ammonia gas. Now see, these are the general uses of some bases. Okay, you read from your book. These are the general uses from some bases. Now the next topic is very important. This topic is test for acidity and alkalinity. Okay, how will you test? This is any other kind of substance. This is acid or alkaline in nature. This is acidic or alkaline in nature. Then you should make a test. Okay, how? First of all, I'll discuss about the ionic product of water. See, ionic product of water. See here, when water decomposes, it produces hydrogen ion and hydroxyl ion, H plus and OH minus ion. Okay, now ionic product is the multiplication of ionic product of water, means we can denote it as a Kw, ionic product of water. Okay, it also depends upon the temperature. The ionic product of water, what is the name of this? Ionic product of water. It also depends upon the temperature. Okay, near about we can say we find out the value near about 25 degrees centigrade temperature. Okay, now see, the ionic product means what? Ionic product means, see, ionic product means the multiplication of concentration of H3O plus ions and OH minus ion. Okay, we'll discuss that. We'll discuss how will you find out the ionic product of water. See, first of all, here water gives H plus ion and OH minus ion, but I said you that H plus ion is not stable. It always, that means as H plus ion it can never exist because this is very unstable. That's why it just goes to the water. Okay, it added water. That means what? H2O when added H plus ion goes towards water and produce hydronium ion. Okay, that's why you can also write Kw is equal to concentration of H plus and concentration of OH minus ion, the multiplication of H plus ion and concentration of H plus ion and concentration of OH minus ion, but actually it cannot exist. That's why we will write here concentration of hydroxyl ion and concentration of hydronium ion and concentration of OH minus ion. Okay, at 25 degrees centigrade, okay, at 25 degrees centigrade the concentration of hydronium ion will be 1 into 10 to the power minus 7 mole per liter. Okay, mole liter inverse. Is this clear? Okay, we'll consider. And also at 25 degrees centigrade the concentration of hydroxyl ion will be same value, 1 into 10 to the power minus 7 mole liter inverse. Now we put this value here, this equation. Now Kw, the value, how will we find out the value of pure water? Okay, that means this is the ionic product of pure water. How will you find out? See, Kw will be, so what will be the value? 1 into 10 to the power minus 7 into 1 into 10 to the power minus 7, and the unit will be, see here, mole, that means mole square liter to the power minus 2. Is this clear? After multiplication, now we'll find out 1 into 10 to the power minus 14 mole square liter to the power minus 2. Is this clear? Okay, this is the, that means this is known as ionic product of water. Okay, at 25 degrees centigrade. Now see, if you add here see, if you adding acid to water, the concentration of H2O plus ion increases. That means if you add acid always gives H plus ion, no? That means the concentration of hydronium ion increases. So acidic nature increases, and that of OH minus ion also decreases. Is this clear? So that Kw, that means the value of the ionic product will remain same. Okay. If an alkali is added, the reverse is noticed. So the nature of solution depends upon the concentration of H3O plus ion in solution. Okay, is this clear? Now, a Danish biochemist Sorensen devised a scale known as pH scale. See, from your book, this is the pH scale. Okay, pH scale which represent the concentration of H2O plus ion of given aqueous solution. Okay, now see, pH, there is a new term pH. This P in pH stands for potence, P-O-T-E-N-Z. Okay, in German, okay, potence. Is this clear? So pH means what? pH means what? See here H. See here H is situated in the power position of this P, na? That means you can say pH means the power of hydrogen. Okay, you can say pH means what? pH is the power of hydrogen. Now, so what is the exact definition of pH? See in your book. pH, the pH of a solution means what? First of all, we write the formula of pH. pH is the negative log of H plus ion, concentration of H plus ion. Is this clear? Base 10. Okay, so the pH of a solution is a negative logarithm to the base 10 of the hydrogen ion concentration. See, expressed in moles per liter. That means this concentration of hydrogen ion, the unit of the concentration of this hydrogen ion will be mole per liter or mole liter inverse. Okay, so if we consider a solution of H plus ions, okay, concentration of H plus ion is equal to 10 to the power minus 12 moles per liter. Then what will be the value of pH? Find out the value of pH. How will you find out the value of pH? See, what will be the formula? pH is equal to minus log of concentration of H plus. Okay, now put this value here. See, 10 to the minus 12. Now minus log of 10 to the power minus 12. Is this clear? Now here also the base will be the 10. That means what will be the value? Minus plus, that means 12. So pH is equal to 12. Is this clear? Now see in your book, it is already given, because here we know log 10 base 10, the value is equal to 1, na? Okay. Now the normal pH scale you all know from 0 to 14. Okay. Here neutral means 7. Okay. From 0, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7. Here 8 to 14. When you moves towards from 7 to 14, that means here it denotes increasing alkaline nature. Okay, increasing alkaline nature. When you move from 7 to 0, here it denotes the increasing acidic nature. This is the normal pH scale, na? Is this clear? Okay. The number 7 means it represents the neutrality of the solution. Okay. Number less than 7, any number less than 7 means pH 654 indicates the acidic nature is increasing as the number decreases. Okay. Number greater than 7, that means pH will be 8, 9, 10, shows that alkalinity increases as the number increased. Okay, is this clear? Now see, when you use the universal indicators means what? See in your book, from your book, see, the universal indicator is a mixture of indicator dyes that gives a spectrum of colors depending on how acidic or alkaline a solution. In universal indicators give different color at different concentration of hydrogen ions in a solution. See, when you use the concentration of hydrogen ion, if the concentration of hydrogen ion will be 1, that means not 1, 10 to the power minus 1, that means the pH will be 1. The solution gives the color as a red. Okay, red color solution. If the pH of any solution will be 3, the solution becomes pink. Is this clear? This is the function of universal indicator. Okay, see, for example, a universal indicator produce green color in neutral solution. That means when pH will be 7, it changes in a basic solution progressively from blue to indigo to violet as pH increases progressively from 7 to 14. The color change in acidic solution is from yellow to pink and then to red as pH progressively decreases from 7 to 1. Okay, see, this is the universal indicator, color change in the universal indicator for pH different value. See, when this is the 7 now, 7 means what? Neutral. The color will be green. When you use the universal indicator, the color will be green. Okay, here also when your pH will be 9, color blue, then indigo, then violet, 11, 13. Okay, see here 3 means pink. pH, the value of the pH means it shows the color pink. 3 means pink, 1 means red. Okay, now see, importance of pH in everyday life. These are the importance. See, first of all, in agriculture, acid rain, you all know the acid rain, medicines, digestive system, preventing tooth decay. Okay, there are all uses. Okay, now the topic of the bases are completed. The topic of this base is completed. Now next class we will start from salt. Thank you.